Okay, good morning. So I hope that you enjoyed your holidays. Now we go back to the topic of quadratic functions. Okay, so the topic today we want to talk about is quadratic functions. It's not quadratic equations. They are related, but they don't confuse them. So here I have a quadratic function. It means that I have a function f, for example, of x, which is equal to ax squared plus bx plus c finished. There is no equal to 0 or whatever. That's a function. It's not an equation. Quadratic function. Okay, so any function of this form is called a quadratic function. Of course, if a is not equal to 0, because if a is 0, this quadratic term is gone, then I have a linear function or a first degree function. So we want to study the properties of these functions a little bit if a is not equal to 0. The simplest possible quadratic function, what is that? Can you tell me? If I want to write the simplest possible quadratic function, what is the simplest quadratic function? Because a quadratic function is a function of this form for any choices of a, b, and c. Of course, a shouldn't be 0. But if I ask you to find the simplest possible quadratic function, can you imagine? Yes? X squared? Yes, x squared. In that case, you choose a to be 1, b0, c0. Then it gives you f of x is equal to x squared. Let us start from the simplest possible case. So for example, let me say I cannot ask you solve this function. It is completely wrong question. There is nothing to solve about functions. We can only solve equations. Okay, that's a function. What is the meaning of a function? I told you before, you need to imagine it as a machine. This box f, you send x in. This function, if you want, it is a squaring machine. When I send x in, it squares it and gives it back to me. That's the function. Do you remember? All possible inputs that I can send into a machine has a name. What is the name? Do you remember? So what is the name of all possible inputs that I can send into a function machine? There was a name for it. What was the name? Yes? The domain. So the set of all possible values that I can send in, the collection of all possible sensible values, is called the domain of the function. And the collection of all outputs that I get for the function, it also has a name. What is the name? Range. Okay, so domain of the function f is denoted by this symbol. It is the collection of all numbers that I can send in. And the range of the function f is the collection of all outputs when I receive if I send all the inputs in. Okay? These are imaginary things. Might be you say this is not practical to understand that, but we will come to it. Okay? So the domain we practice a lot, if you remember. And I told you that you need to understand what a range is, what the range is, but probably you will not be asked so many questions about finding the range. But this is an exception. For the quadratic function, we will come to see we can be able to answer the range of the function fairly simply. Okay? But can you tell me what is the domain of this function? Think in that way. What are the possible input values so that this function makes sense? Yes? All numbers. Because I do not have any problems. Whatever I choose for x as a number, x to power 2 is meaningful. So if I ask you what is the domain of this function, what is your answer? Is the set of all real numbers, or you can write it in words, the set of all, the collection of all real numbers. Okay? Okay, I haven't told you how to calculate the range yet, but I think you have a feeling what is going on. For example, do you think that 4 is in the range? Yes, why? For which input 4 is the output? Yes? 2 and minus 2. One of them is enough. Because if I send 2 in this machine, I get 4 out. And if I send minus 2 also to this machine, I also get 4. So 4 is in the range because it was produced by some input. For example, if I ask you, is 2 in the range? Yes? If you say yes, you need to tell me which input causes 2 as the output. Square root of 2 or minus the square root of 2, but one of them is enough. So 2 is also in the range. Is 0 in the range? Yes or no? Yes. For which input? Only 0. If I send 0 in, the machine will give me 0 back. Yes? So it means that 0 is in the range. But let me ask you this question. Do you think that minus 1 is in the range?
No.
Why? Because if minus 1 is in the range, it means that I should be able to find an input for which the output is minus 1. But this is not possible because it doesn't matter what I send in, the function squares that and gives it back to me. Yes? But if I send a number in, x squared cannot be negative. So I immediately understand that this is in the range, this is in the range, this is in the range. This is generated for 2 inputs, 2 and minus 2. This is generated for 2 inputs, minus square root of 2 and plus the square root of 2. This is generated only for one single value, and that is 0, but this cannot be generated at all. So minus 1 is not in the range. Okay. Do you have a feeling, if I ask you what is the range, can you express it in words by this observation? If I ask you what do you think the range of this function is? Yes? Every non-negative number. Yes? So every non-negative number. Yes? So this is something we always talk about functions. When I introduce a function, this is always a reasonable question. The reasonable question is not solve the function. There is no meaning to this. But I can ask you what is the domain of the function. I can ask you what the range of the function is. This might be harder than this. We will come to the harder questions, but this is essentially the essence of this thing. So I can ask about domain. I can ask about the range. What else I can ask about the function? A very important notion. Yes?
What happens if I put in this number in the function? Can I ask a question like that?
What?
What happens if I put in this number?
Yeah, we already, yes, that's correct. So for example, you are saying that I can ask what is f of 7. Okay, what is f of 7? It means that I am sending 7 to this machine. So what is the role of this machine? It takes the number from me, squares it, and gives it back to me. So it is 49. Okay, I can ask the other way around. For example, I can ask for which value f of x is 3. Okay, then I can solve it. I would say that f acting on x gives me x squared equals to 3, so x becomes plus or minus a square root of 3. So yes, these standard questions we can also ask. I can ask something about, in Swedish they call it nollställe, but this means the zeros of the function. So I can ask you, what are the zeros of this function? So what does it mean? It means that I am asking for which value f of x is what? 0. So when I ask what are the zeros of a given function, it means that I am asking for all possible inputs who are responsible to generate 0. Okay, so how can I answer this question? F of x is x squared equals to 0. I find x. There is only one answer to it, and that's 0. So these are the sensible questions we can ask about functions. What are the zeros? What is the value of the function at this point? For which input I get this number as output? What is the domain? What is the range? But there's also one essential thing that we usually use GeoGebra. Yes?
Is it when you type in the function and then you could see the lines?
The graph.
The graph.
The graph. So the graph of the function is also very important. So these are the questions that you can answer, or it is reasonable to ask about the function. So what the graph of the function is. So if this term is not there, b and c are some different numbers, do you remember what the graph is? It's a straight line. Yes, if I have a linear function, for example, if I give you y, by the way, sometimes the output is usually called y. Okay, this is a standard in mathematics. So usually we use letter X for the input, the letter Y for the output. Yes? So when I say, for example, Y equals to 2x plus 5, do you remember? We had this in Math 1C. So I can ask you what is the graph of this function based on what we discussed before. So you know what is the graph of this function if you draw it. It's a straight line. For example, in that case, I could ask you what is the slope. You can tell me it is 2. Yes? Is that clear? Now, in the same way, we want to ask what is the graph, how the graph of this quadratic function looks like. Okay? But that's a harder question, yes? Yes. So, but I just want you to understand, drawing a graph is not an easy task. So you will learn in Math 3C and Math 4 how to qualitatively draw a graph by hand. Okay? But we can discover some of these properties for this simple function today. So the reason that the graphing of a function is usually essentially hard is because what is the essential way of drawing? What is the crude way of doing the of drawing the graph? Yes.
You go for every value.
Yes, and then find them. You don't attach them. You don't connect them. But if you find all of them, if automatically they are connected, they are connected. If they are not connected, they are not connected. Okay? But I want you to see that this is impossible. Because how many inputs I can send for this very simple function in? Infinitely many. I can, according to what you told me, the domain is R. So I can send every possible number in, infinitely many, and I will of course get infinitely many out. Yes? And then there will be infinitely many points. I will not have enough time to find all the points. Yes? Is that clear? So practically, if you want to do it like this, it is not logically possible. Okay, so that is why we need more mathematics to guarantee that what we draw by hand captures all possible important features of the graph, which you don't need to bother about. This part, we will study that next year. Yes?
Can I just not put in several different...
Several different points is good, but that's an approximation. I want you to feel, this is what we will do, but I want you to understand why this is in principle not 100% correct. Okay, so for example, for this function, I will follow what Hasbulat mentioned. So I will draw a table, for example, vertical or horizontal, doesn't matter. So one row X, one row Y, input, output. Okay, and then I have my function. Let me call it Y equals to X squared. Okay, so for example, I put 0 as my input, X. What do I generate as the output? 0. For example, I put 1. What do I generate? I put 1 here, I will generate 1. I put 2, what do I generate? 4. Yes? For example, let us put some negative numbers. I put minus 1, what do I generate? 1 again, and if I put minus 2, I generate 4. And then I will try to find those points, highlight those points on my screen or on the whiteboard. Yes, so 0, 0 is this point. And then 1 and 1, this is 1, this is also 1, that is another point. 2 and 4, so this is 2, 2, 3, 4. This becomes another point. And then I go to the negative 1, it is still 1, so this becomes another point like this, and then I have minus 2, and it becomes 4 again. Okay, so these are the points. But I have infinitely many ways to connect them. Yes, might be, I don't know, some of you say that, okay, I want to connect them like that. By the way, it's not a very bad picture, it's close to reality, but I want you to see that this is not working, yes? Some of you might say that, okay, no, I want to connect it in that way, which is closer to what is real. But I want you to feel, I will draw the red one for this, but you have all rights to ask, why do you think this is the correct one, the orange one is not the correct one? How can I answer this question? For example, how should I say that the red one is closer to what is real than the orange one? Okay, then I would say that, okay, let me, if you don't believe me, choose one half here, put one half there, you get 1 over 4, and then you find 1 over 4, then you will see that this one lies on the red one, not the orange one. But of course, I hope that you agree with me. It doesn't matter how many points I provide. Still, I cannot be sure from here to here is exactly this red one. Do you understand what I mean? For example, if I have a lot of points, okay, so one person might draw it like this, one person might draw it like this. I mean, there are infinitely many ways that I can draw, yes? So the problem is that how should we know that this is the graph, not this curly one? My point is to understand that no matter how many points I calculate, still the question remains the same. Yes, if I increase the number of points, of course I have a better approximation, but do you agree there is no unique way to connect this one to this one? So how do you know that this to this one is connected in that way, not in this way? You say that, okay, I find another point, but I can ask the same question between those points. Okay, so that's what I want you to feel. This is not today's lesson. This is not this year's lesson. Okay, I want you to feel drawing the graph of the function using this method is not probably a very logical way to do it. If you see GeoGebra, for example, if I ask GeoGebra to draw the graph on your screen, you will see this, something like this. But I want you to understand, because you just see this on the screen, it is not guaranteed that this is the graph. Do you agree with me? Because might be this is your screen, because the screen has a limitation. How do you know that this function is not going like that and you don't see it? You might say that, okay, I scroll a little bit to the left, to the right, and I see nothing strange happens. But how do you know that this strange behavior is not happening here? So that's what I'm saying. I want you to feel that the question is relevant. So the reason GeoGebra shows this part to you, because GeoGebra already knows the answer somehow. So they have programmed it in a way that it tries to capture the essential feature of the graph. Okay, so for example, this point and that point are called turning points. So GeoGebra knows how many turning points are there in the graph. Okay, so it tries to capture the essence of the whole function, but still there are many functions that you will see on a screen that you don't see the whole quality of the graph. So this is, I want you to understand that the graphing of functions by this model is not very bad, but it is always approximation to what you are supposed to get. Okay? So even if you have a tool like GeoGebra to draw the graph, essentially this question is still open. How do I know I will not get any interesting parts of the graph outside of the screen that I am looking at? Okay, how should we be able to answer this? This is coming from the notion of derivative that you will study next year. So this I want you to keep in the back of your head, that this question is still open. But for these functions, this is the best we can do. Okay? Okay, and then, so can you see that, for example, this is also a good question to answer. So this is the graph. I want you to remember the form of this graph somehow. By the way, there is a name for the graph of the second degree equations. It is called a parabola. Okay, so when we say a parabola, it is the graph of any second degree function. Yes, it's called parabola. I want you to know the name. It's also mentioned in the book. Okay, so you see that this is a very bad picture. So do you see why this is a bad picture? In principle, I could do a little bit better. Yes, it should be, what did you say? It should be symmetrical. Symmetrical with respect to the y-axis. Can you see why it is symmetrical? Why it should be symmetrical? So let me give you this function, y equals to x squared. And I ask you, if you draw the graph of this function precisely and good enough, this function should look symmetric with respect to the y-axis. Can you tell me why you should expect such a thing? Yes? Exactly. So whatever I have with positive, you see, when I have 1, I have 1. When I have -1, still I have 1. Okay, so how these points are related? So this point 1 and 1 is here. The second point has the same height, but the opposite x. So it becomes where? It becomes exactly the mirror image of this point with respect to the y-axis. So when I have 2, I had 4 here. Okay? Another point is -2, but the height is still 4. So that is exactly the mirror image of that point here. So every point that you have on the parabola on the right, it has a mirror image of that point on the parabola again. So it should be completely symmetric with respect to the y-axis. So this is something that is essential for this function. For example, if you write y equals to x to 3, and then if, of course, this is not lesson, our lesson, but if you draw the graph of this function, the graph of this function looks like this. So it is not symmetric with respect to the y-axis. And that is understandable. Why? Because if I choose 1 and 1, if I flip the sign of 1 to -1, what will be my output? -1. So it is not the point on this one. So 1 minus 1 will be here, but it does not satisfy the equation, so it will not lie on the graph. So it is not symmetric with respect to the y-axis. Okay, so this function is symmetric with respect to the y-axis. And of course, now I can draw it a little bit better. Okay, not very good, but anyway. So this point is called the turning point. The turning point. Okay? And this is the lowest level of this curve. So this is why sometimes they call it the minimum point. Okay? So if I ask you what is the minimum of this function, what do you say? When I say what is the minimum of a function, it is the lowest height of any point on the graph of the function. So what is that? 0. Okay? So minimum is 0. So when I say minimum, I mean the minimum of y. The minimum value of y is 0. And it is attained where? It is attained when x is equal to 0. So when I ask you what is the minimum of this function, I mean the lowest height of the points on the graph of my function. It is 0. I can ask you when this minimum is achieved. You will tell me when x is equal to 0. Yes?
Can a graph have two minimums?
Not quadratic ones. Yes, we can have 2 minimums. For example, I can have something like this. Yes. But of course, there are 2 different minimums. One of them are called local minimum, and the other one is called absolute minimum. I don't want to confuse you with those things, but we are only talking about the quadratic functions. This is the simplest quadratic function that we have, but it already captures the qualities of the quadratic function. So we learned that it has a symmetry line. By the way, this line that splits the graph into 2 identical parts, symmetric parts, is called the symmetry line. You want to study this, of course, for harder ones, but this is the thing that I expect you to learn. So it's symmetry line. So symmetry line is the line that passes through the turning point, and it splits the graph into 2 symmetric parts. Yes? Is that clear? So for example, if I ask you, what is the equation of the symmetry line? Can you tell me what is the equation of the symmetry line? Symmetry line is an object, it is a line. Every line has an equation. Do you remember? This is an equation for a line, yes? But this line is vertical. Do you remember what was the slope of vertical lines? What is the slope of horizontal lines? The slope of the horizontal line, yes. No, be careful. So what is the slope of a horizontal line? A slope is the name, is a good name on it. If you have a horizontal line, what slope do you have? There's no slope, so it is 0. Yes? So horizontal line has a slope 0. So if I ask you what is the equation of this line, let us say this is 5. If I ask you what is the equation of this line, y equals to 5. Why? Because no matter which point you are choosing on this line, all these points share one common property, and the property is that the y coordinate of all of them is equal to 5. So that is y equals to 5. But let us say here is 10. And then I draw a vertical line. Let me ask you this question. What is the slope of this line? What? No, a slope. There is no slope. A slope is not defined. Remember, for vertical lines, a slope is not defined. But if I ask you what is the equation of this line, it means that if you consider the points on this line, what can I say about them? I can say that x of all of them is equal to 10. So that's the equation of this vertical line. And if I have a non-vertical, non-horizontal line, it would be of that type. Okay, now can you tell me, if I ask you, show me the symmetry line by your finger, you show me this. This is an object, that's a line. But I can ask you, what is the equation of the symmetry line? What is the equation? X equals to 0. This is y equals to 5. This is x equals to 10. So, but this is x equal to what? It is passing through 0. So x equals to 0 is the equation of the symmetry line. Yes? So when I ask you, because I have seen, when I ask some students write the symmetry line, give me the equation of the symmetry line, many students just write 0. 0 is not an equation of a line. An equation means having equality in it. That's the meaning of equation. So 0 is just a number, it's not an equation. But when I say write an equation for the symmetry line, this is what I expect you to write. And of course, I want you to understand what the meaning is. Yes, is that clear? Okay. Now, this is a turning point, but this turning point is of minimum type. By the way, can you see from the figure that what we guessed about the range is correct? Yes? The range, do you remember? If I ask you what is the domain, it means that you need to imagine that you are shining light from above, and then you see the shadow of this object on the x-axis. That shadow is actually the set of the domain of the function. And if you do it from left and right and find the shadow on the y-axis, that shadow is what we call the range. So if I want to find the shadow on the y-axis, do you agree? This is the shadow of exactly that point. This point is the shadow of these 2 points. So every point here will be covered. So the shadow will be something like this, which starts from 0 above. And that is exactly what we wrote. Every non-negative number is in the range. But what is the domain? You might think that when I do the shadow here, the shadow is just here. No. This point is also in the shadow because I don't have access to the higher parts of the graph. If I do that, then I will see that this point is also a shadow of some point up there. Yes? You have questions?
Are you sure that that line stretches all the way to the x?
Yes, I am sure. But how? That's why I'm saying mathematics is better than having tools. Because when you draw this, you might get this feeling that, okay, might be this reaches here, but it will never reach up there. But how should I know that this will happen? No, GeoGebra is not good because GeoGebra, for example, how do I know that? Okay, if I have a bigger screen, I might see some part of the graph up there, but then I go to the next room. Then what happens? How do you know that there is a point up there as well? Because this will give you a wrong feeling. Let me just do it in GeoGebra that you can see. Okay, so for example here, and you see it, yes. So let me double check it, yes. It's working. Okay, so if I put y equals to x to the power of 2, that's the graph. Okay? Okay, so what Hasbulla said is good, is a good question, because how do you know that? When I go up, I will see the graph up there from -10. It seems that the graph will not reach to -10. Okay, one way, of course, is to you see here, and still I don't see it, you see, Up there, I don't see. I can say that, okay, wait. I don't know how much we should wait, but it is not a good idea. Yes, but still it's up 10. You see, we don't see any graph yet. But then I continue, you see. Yes, finally. So finally I have this point. So minus 10 was indeed in the domain. But now let me ask you minus 1 million. How do you know that minus 1 million is on the graph? That's what I'm saying. Even if you have GeoGebra available, answering some of these questions need your thought. Yes? Yes?
I know that because the x-axis is what you put into the function, and as long as you can put in the number,
you get something. So that's exactly the answer. So how should I know that minus 10? So let me choose 10. How do I know that there is a point of this curve up there? Because I can put 10. If I put 10, what do I get? I get 100. So the point with coordinates 10 and 100 is far away on my screen, but it is on the graph. So that's why I'm saying that even if you have a good precise tool as here, you need to also, it doesn't make you independent of thinking and mathematics itself. Okay? Any questions? Okay, so let us go back to home here. And this is the minimum point. Okay, now my question is that, by the way, there is also a feature in GeoGebra, so you can go here. Let me see. This is the extremum points. So I can click on it. It gives you the turning points on the graph. So then I click here, and then you see that I have my turning point with coordinates 0 and 0. It's good to know how GeoGebra gives you the extreme points. These points, the turning points, also have a different name. So sometimes they are called turning points. Here in this case, the minimum point because it is the lowest one, and sometimes they are called extreme points. Yes.
if the parabola was upside down,
Yeah, that's the next level I want to talk about.
Is that also still a shadow? Is the shadow still in the middle if the parabola is upside down?
What do you mean in the middle? Let me talk about that. Okay, so before discussing about the function, the quadratic function in general, let us answer what he is referring to. So let us try to find another function. I still want to keep it simple. I want to keep it second degree, but I want to have a maximum point this time. Okay, so can you guess what will be the function? Yeah, minus x squared is the simplest of those functions. Yes? Okay, let me again review everything. So let us say that, let me call this function g of x. If you want to view it in this way, you can say that I have a machine g, I send x inside. What does this give back to me? It gives me negative of x squared. Okay, so can you tell me again the same questions I can ask about this function? Why this is today's lesson? Because it is a function, and it is quadratic because of the second power. So that's under this title. So if I ask you what is the domain of function g, what is the domain? The domain was the set of all possible inputs. So what is that? Anyone else? Yes, the same. Every number I can still send in. Yes, any number I want, I can send in. So the domain is R. But let me ask you the question again. Do you think that 0 is in the domain, is in the range? Is it possible to get 0 as the output? Yes. For which value of x? 0. If I send 0 in, the output is 0. So this is in the range. Is minus 4 in the range? Yes. For which input? For example, 2. If I send 2 in, the answer becomes 2 to power 2, 4. There is a minus sign here, it becomes minus 4. So minus 4 is in the range. But do you think that 1 is in the range? No. Because when I send something in, it squares that and multiplies it by minus sign. it becomes always negative because x squared is non-negative. When you multiply it by minus sign, it becomes negative. So 1 is not as the output. Okay, so if I ask you your feeling about the range, what is that? Every non-positive number, yes? Because non-positive is different from negative. When I say non-positive, it means it includes 0 as well. So every non-positive number. Okay, now let us try to ask what is the graph, how the graph looks like. So I will draw a table again, x and y. So let me put the same numbers, 0, 1, 2, minus 1, and minus 2. If I put 0, it becomes 0. If I put 1, it becomes this function. It becomes minus 1. If I put 2, 2 to the power of 2, 4, minus 4. If I put minus 1, what's the answer? What? Are you with me or not? Hello? What is the answer? You mean minus 1 again. Don't hesitate, because instead of x, I put minus 1 to the power of 2. There is a minus sign outside. So this part becomes 1, but this is minus 1 again. If I put minus 2 to power 2, minus sign. Minus 2 to power 2 is 4. There is a minus sign. So there's also minus 4. And then if I want to sketch the graph, this is why I don't ask you to draw. I usually ask you to sketch the graph, yes? X and y. So 0 and 0 is here. 1 and minus 1. X is 1, y is minus 1. It is here. Yes, it becomes exactly upside down. So it is 2 and minus 4. And then I have minus 1 and 1. So, sorry, minus 1 and minus 1, minus 2 and minus 4. Yes? And then I draw the graph something like this. So do I have a turning point here as well? But the turning point is of which type? What is the nature of this turning point? It's not a minimum point. It's a maximum point. Yes? But still, this is the turning point. So that's called the maximum point here. Is there any symmetry line here? If I draw it perfectly fine, I hope that you agree with me. It's still the same line as the symmetry line. What's the equation of the symmetry line? What's the equation of the symmetry line? X equals to 0. What are the coordinates of the turning point, which is the maximum point here, is 0 and 0. What is the maximum value? What is the maximum value? No, what is the maximum value? It means what is the highest value? Value is always y. What is the highest y? What?
Zero.
No, what is the highest y? What is the highest height? Value. When I talk about value, the highest value, what is the highest height? It is 0. I do not have something above 0. So the highest value is 0. It is achieved when x is also 0. Okay? So be careful about it. Okay, so this is something that we want to learn, but not for all these simple functions. Let us try to investigate what happens if I increase the difficulty of the function. And this question I want to ask now. So, for example, let me give you this function. Y equals to x squared plus 2x plus 2. Okay, so let us try to investigate this function. This is still today's lesson. Why? Because it's a quadratic function. Okay, I can ask you a lot of questions. For example, the first question I can ask you about the domain. So what is the domain of this function? What is the domain? It means what is the set of all possible input values? Yes? It's still the same real numbers. Yes? Do you agree? So that is all. But the question of range is not that simple to answer right away. So what is the range? Yes? What is the range of this function? For example, let me ask you one question. Simple. Do you think 2 is in the range? If you say yes, for which input?
0.
For 0. Because if I put x to be 0, so let me think in this way. I send x in, I get x squared plus 2x plus 2 out. Yes? Okay. So, is 2 in the range? You said yes, and it is true. Why? Because when I send 0 in, what do I get as the output? 0 plus 0 plus 2, which is 2. So 2 is in the range. But for example, if I ask you, is 5 in the range? How do you answer that? You need to ask yourself, what? Is there any input for which the output is what? Is 5. If the answer to this is yes, then yes, 5 is in the range. If the answer to this is no, we say 5 is not in the range. But how can I answer if this is yes or no? Yes, Ahmed?
Move the 5.
We solve it.
Yes.
Now it becomes quadratic equation. So be careful. Today's topic is quadratic functions. It is in principle not the same as quadratic equation, but it is relevant to the topic. So in order to answer some questions relating this function, I have to solve the quadratic equation. So I would say that x squared plus 2x, I move 5 to the left, it becomes minus 3 equals to 0. Okay, so then you see that you find delta, yes? Let me write, you find discriminant. Let me write discriminant, not to get confused with this d. So what is discriminant here? Is b squared, do you remember? Hopefully, b squared minus 4ac. So b squared is 4, minus 4 times that becomes 12 is 16. Okay, I don't need to find that number because I want to convince myself there is a number. But do you think there is a number or not based on this calculation? Why? Because the discriminant is positive. How many roots do you have? 2. 1 is enough for me. So, again, so 2 was in the range. Is 5 in the range? Yes. Yes? I didn't answer the question which input will give me 5. But I convinced myself and hopefully you that there is a number for which the output is 5. And this means that 5 will be in the set of my outputs. It is in the range. But let me ask you this question about, I don't know, about, for example, minus 10. Do you think minus 10 is in the range or not? Technically speaking, that's the same question. Well, I have to redo it again. It means that I have to ask myself, is there any input for which the output is what? Is minus 10. And then I answer this question. If the answer to this question is positive, yes, minus 10 is in the range. If the answer to this question is negative, it means minus 10 is not in the range. Yes? So what do you think is this? Again, I move it to the left. It becomes 12. And then I find the discriminant, which is b squared minus 4ac. b squared is 2 to the power 2 minus 4 times a times c, which becomes 4 minus 40a. It becomes minus 44. So what do you say now? Discriminant is negative. It is an indication that the equation doesn't have any roots. So it means that is minus 10 in the range? No. So case by case is simple. It's not a hard question. But if I ask you, what do you think about the totality of the range? You cannot do this forever. This is why I'm saying that range is a hard question, especially in the high school level, but we can use it, you can use graphical tool. But in the case of quadratic equations, it is not hard. Can you tell me, I want you yourself be a little bit creative. Can you find a way that I can find the range and tell you that this is the range without checking it case by case? Checking case by case is also important to understand, but it is not practical because there are infinitely many possibilities. Do you have any idea of what to do? Yes? Okay, that is first of all, you say I don't think. We want the definite answers in mathematics, yes? Okay, so you are telling that there is no possibility for having negative numbers, yes? But do you think it is a possibility, for example, to have all positive numbers? Okay, so that is your belief. Okay, so let me try to test you with this 1/2. So let me ask you the same question with 1/2. 1/2 is a positive number. Do you think it is in the range? Let us check it. So it means that is it possible to find such an x for which the output is 1/2? What is that, sorry? Yes? Let us check if that is true or false. So how should I do that? It's better to get rid of this fraction by multiplying by 2. So it becomes 2x squared plus 4x plus 4 equals to what? Equals to 2. I multiplied by 2. Oh, sorry, by 2 it is 1. I move 1 to the other side. It becomes 3 equals to 0. And then I calculate the discriminant, which is b squared minus 4 times 2 times 3. Yes? So it is 16 minus 24, which is negative. So it means that even though 1/2 is positive, but 1/2, is it in the range or not? Not. So what you said is not 100% correct because there are still some positive numbers that are not within the range. Yes, so 1/2 is not in the range. Yes?
The range is 2 and everything above 2.
Okay. So you say 2 or above 2. These are good questions. Let me see. You say 2 or above 2. So, for example, 1.5 shouldn't be there. Is it a feeling? Okay, so 1.5. Is 1.5 within the range? Yeah, 1.5 is within the range, I agree. But you said, no, you said is not in the range. Yes, okay, let us check. So, is there any number for which the output is 1.5? So to answer this question, I move this to the left. It becomes 0.5 equals to 0, yes? And then what is the discriminant? Is this 1 to the power 2 minus 4 times this times that? Yes, you are right, there is. So 1.5 is in the, okay, 5.0 is in the range. You said it is not in the range. Yes? So this is 4 minus 2, which is 2 and positive. So I just want to feel that if I feel this is the case, if I feel this is not the case, it's not working. Because you felt that this shouldn't be in the range, but I hope that I could convince you that yes, 1.5 is in the range. But how is the systematic way of thinking it? Because even if you can succeed to guess, I would call it coincidence, because you have to be able to defend it. So how do you think I can convince you about the full range? Yes?
Is the range every number greater than -1?
No. No. No, but you don't guess. Find a systematic way to answer my question. I can give you a hint. You need to complete the square somehow. Yes?
Every number except negatives and 0.
I don't know, but defend you. Because if you say this, if I ask you why, you should be able to defend your claim.
Because 0 or 0.5 or 0.7. It can only be 1.
No, x squared can be 0.5.
But then
So, for example, if I ask you, is it possible for x squared to be 0.5? The answer is yes. What that number is, square root of 0.5 or minus square root of 0.5. It is possible for x squared to be 0.5. No clues? It's not hard, by the way. Okay, so let me tell you what to do. Might be you can find. I would write it in this way in my head. Why do you think it is useful? You might say why you broke these two into two parts, 1 plus 1. There is a reason behind that. Yes? This tree becomes a complete square. So what can I write? I can write x plus 1 to the power of 2 plus 1. Yes or no? Okay. But look, when I say what is the range, I am asking you about all possible values of y. But one thing is clear. This number, whatever x is, I don't know what x is. X has infinitely many values. But one thing is clear. The result of this calculation is non-negative. Yes or no? Because whatever x is, positive or negative, I add 1 to it, it becomes a number. I don't know what that number is, but I know that I am squaring it. So that number is not negative, or it is at least 0. It cannot be less than 0. Yes? And now look, what is the possible value for y? Whatever this number is, I am adding 1 to it. So can you tell me what is the whole combination? The whole combination is greater than or equal to 1. Yes? Is that right or not? This one is greater than or equal to 0, but I am adding 1 to this combination. If this number is minimally 0, the whole combination will be minimally 1. Is that understandable or not? Yes or no? Okay. So what is the range? The range is greater than or equal to 1. Every number greater than or equal to 1 is in the range. Is that right or not? Understandable? So what is the range of this function? The range of this function is all possible values y greater than or equal to 1. So this is why this is the range. So if I ask you what is the range of this function, what do I expect you to write is to write this. Okay, if I ask you what is the minimum of y, what is the minimum of y? Lowest possible value of y is 1. Yes? And now if I ask you how can I achieve the minimum? For which value I reach to 1 as the minimum value? 0. No. If I put 0 here, it becomes 2. So when I put 0, I do not get my minimum. In order to get my minimum, which input I should put in? Minus 1. Because if I put minus 1 here, this achieves, it reaches to its minimum. It means that y also achieves the minimum 1. So the minimum value is 1, but it is achieved when x is equal to minus 1. So the turning point is of which type? Is it of minimum type or maximum type? Because you realize that we have two types of parabolas, of this type or of this type. Which type of parabola do you think you will face when you draw it? This type of parabola, upside down parabola, or this type of parabola? Which one? The upper one or the lower one for this graph? The upper one, because it has a minimum. It doesn't have a maximum. Yes? So the minimum value is 1. It is achieved at minus 1. So can you tell me what is the minimum point? Minimum point or the turning point is what? What is the x coordinate of the turning point? Minus 1. What is the y coordinate? 1. That's the turning point. Yes? So let us just do it using GeoGebra to see how is it going. Yes, please.
X is the main and the y is range, right?
Yes. Okay, so here, if I go to GeoGebra here, I will type this in. So y is equal to x to the power of 2, and then I have plus 2x, and then I have plus 2. Oops, plus 2. And this is the graph that I will see here. Okay? And now you see this is the lowest value. But this lowest value is how much? Is 1. The height is 1. It is achieved when x is equal to minus 1. I can go to this feature of GeoGebra. I can click on it. I choose the extremum point, and then I click here. And it gives you minus 1 and 1. Minus 1 and 1 is the minimum point of this function that we found. Yes? So this is the idea. The idea is to complete the square. Because when you complete the square, you can say about the minimum value or maximum value of a complete square. And then whatever number you have here, that will play the role of y maximum or y minimum depending on the nature of the parabola. Is that right? So I want to practice on this now. I want to give you a little bit different function, and I want you to ask all features possible for that function. Okay, so let me change the function here. Let us see how you do this yourself. Okay, if you do this one yourself, in principle, you learned what is the goal of this lesson. Okay, so let me write y equals to, let me make it simple, not very hard, x squared plus 6x minus 7. I want to wait for you, okay? So I want you to answer these questions. I want you to find the turning point. The turning point. The other question is that is it max or mean? I mean, the turning point can be a max or can be a mean. Which one is in this case? The next question is that what is the symmetry line? I can ask you what is the domain. I can ask you what is the range. These are the questions that you will be asked. By the way, I can also ask something. What are node stelle, or what are the zeros? Zeros, if any. Okay, so these questions, these are standard questions. You should be able to answer these questions fairly simple, very comfortably. Okay, so I want to wait for you. We do it together. How do you answer the question? So you learn that the trick is what? Completing the square. Okay, so what I do, so might be, if I want to complete the square, what is the suitable number I need to make a complete square with these two and the number? What number I need? What number so for example, this minus 7 is not a good number for having a complete square. Which number is needed? If I take this off and I ask you which number to put there so that the whole expression becomes a complete square, what do you answer? 9. So you just add 9. But you cannot just add 9. When you add 9, because 9 is not there, to compensate for that, you have to subtract 9 as well. And then I have a minus 7 as well here. And that is why, Hasbullah, you made the mistake. Yes? So first of all, do you understand what's happening? I added a 9, and I took the 9 away, so I did nothing. I have to do this because I don't want to change the problem. The problem is to find the range or whatever about this function. When I add 9 to this, I have to subtract 9 because 9 is not there. So now 9 and 9 are gone. You might say, what is the benefit? What is the benefit? Is that these 3 now becomes a complete square, which is x plus 3 to power 2. And then I have minus 9 minus 7, which is minus 60. Yes or no? So that is the way that you have to do it. The rest of it is the same. This one is a complete square. So what is the possible output? The possible output, I don't know what that is, but I know it is non-negative. Yes? So this is a number greater than or equal to 0. Can you tell me what will be the combination? What can I say about the combination? Do you agree? Everyone agrees or not?
Yes.
Because this expression is equal to this, is equal to this. So whatever I say about this, it's the same for this, because they are the same. But this part, because of this even power, is non-negative. This one is non-negative, this is minus 16, so the whole expression is greater than or equal to minus 16. Why? Because this is minus 16, and I am adding a positive number to it, so it becomes greater than or equal to minus 16. Okay, now let us try to answer these questions one by one. According to this observation, what do you say about this turning point? Yes? Minus 16 is which one? No. You see, this is y greater than minus 16. So that's the y value. So x value, so this is the y value. Yes? And what is the x value, everyone? X value. So why are you confused? You don't have time. Don't be confused, please. Yes? Minus 3. If I want to reach to minus 16, what input should I provide? If I want to achieve the goal of minus 16, it's in the range, I have to put x equals to minus 3. So that is minus 3. Okay? This is the turning point. Is it a max or a mean? Is it a max or a mean? Y is greater than or equal to minus 16. Is it a max or a mean? Which one is that? Tell me. Mean. So it's a mean point. What is the symmetry line? What is the symmetry line? The same as? Not the same as turning point. This turning point is the point. I want the symmetry line. How they can be the same? X equals to minus 3. And if you just write minus 3, you will not receive any points. You need to show that you are respecting the question. So what is the domain? The domain means the set of all possible sensible inputs. There is no limitation for that, so domain is R. But can you tell me what is the range? It's on the board. Yes, y greater than or equal to minus 16. So that is the range, sorry. This is the range. What are the zeros, if any? To answer this question, it means that put this equal to 0 and solve it. Yes? Okay, and then you know how to solve it. So I calculate d. What is d? 6 to power 2 minus 4 times 1 times minus 7. So it becomes 36 plus 28, which is 64. So x becomes minus b plus or minus the square root of d over 2a. So it becomes minus b, which is minus 6 plus or minus the square root of this is 8 divided by 2. So I have two zeros. One of them is minus 6 plus 8, 2 divided by 2. The other one is minus 14 divided by 2. So these are the type of questions that you might receive about quadratic functions. So these questions, I cannot change them that much. The questions are always the same, but the functions can be changed. It could be a little bit harder than this. We will practice it tomorrow. Okay? Any questions? Thank you very much.